So having looked at the building blocks of how we build out tenants and VRFs and EPGs, let's look at that in a bit more detail. There are really a few basic ways that customers build out the network. And we'll start with what I call as standard networking. So this is option one, so just basic networking. I've got a VRF, again, that's going to sit inside a tenant. I've got a subnet, so a bridge domain. And then I've got an EPG or a VLAN attached to this. So this is your standard building block. Every customer, every ACI customer builds exactly like this to start with, because this is what they've always got in their network today. Today they always have a VLAN, which is at this layer, and they always have a subnet, which is at this layer, and a VRF at the top. So they always have this. So your standard networking just adds on to this. So I've got a VRF, I add a second subnet, a second EPG, a third one, and so on and so on. So this is very basic. This is really taking exactly what customers have today and replicating that on an ACI fabric. So the nice thing with your option one, your standard approach, is that it's very simple to explain to customers because it just builds on things they know. And as I mentioned before, what is different with ACI is that if I want to talk from group one to group two, I need to put an access list or a contract, as it's known in ACI. I need to put a contract in place that allows me to talk from group 1, VLAN 1, to EPG 2, VLAN 2. So I have to have this in place before any communication is allowed on the network. So option one is very straightforward, very simple. Every customer is going to build this. Option two is slightly different. So with option two, what I can do is, if I remove this very quickly, option two allows me to have multiple groups of servers on the same subnet. So this is counterintuitive for most network people. Most network people would think, I've got a VLAN, I've got a subnet, that's a one-to-one match. In ACI, we can build this though. We can build multiple EPGs, multiple groups of servers, all sitting on the same subnet. So an example where this is useful, I had one of the universities in the city in London. They had a requirement, they had all of their web servers sitting on a single subnet. And what they wanted to do was break those web servers into different groups of web servers. So a group for application 1, a group for application 2, and so on and so on. So they didn't want to allow crosstalk between those groups of servers. And with ACI, that's very simple. I build my subnet. They've already got that in operation anyway. All I need to do is apply 3 EPGs to the network and attach my servers to these EPGs. And now they can't communicate. They can talk out through their default gateway up here. And if they want to talk to the next tier of the application, we simply put a contract in place that allows this EPG to talk to a different EPG, and that's it. I've now got connectivity across the network. And again, the missing part is I'm going to draw a box around all of these EPGs, and these would form what's known as the application profile. And when customers are deploying a network, they often get concerned or confused around how they should call their application profiles. There's no right or wrong way. It's really a case of what makes most sense for the customer. So in this case, I've not given my application profile a name or anything like that. But if we think about this, how I could construct this, I could have an app profile for me. So it's my app. And underneath my app, I've got an EPG for my web tier, my app tier, and my DB tier. And I would call that Steve's app. Alternatively though, I could call this, Steve's app, and I've got VLAN 10, VLAN 11, and VLAN 12. So it's just a naming convention that you need to help the customers decide upon. If they can name their network constructs based on an application name, as we've got here, then it makes much more sense for them from an auditing perspective, a configuration management perspective, and knowing the rules of data flows across their network. However, if I name it, VLAN 10, VLAN 11, VLAN 12, there's nothing wrong in that. It just means that they need to take that name, VLAN 10, and relate that back to the services that are presented on VLAN 10. So it's just another step they need to do. Again, no right or wrong, just two different options that they have. So we've looked here at option 1 and option 2, and I'll share a slide with you now so you can actually see this in a lot cleaner picture.